Hi gang, it's our last lesson out of chapter 10 here. Last conic section we're going to look at. Maybe the most useful or practical anyway, the ones you see around on parabolas. Again, the definition for parabola is quite similar to some of the other conic sections as you remember, with just a little difference. A set of all points in a plane that are the same distance from a given point, there's that focus point again, and a given line, that's this line called the directrix. So in this definition, this distance will always be the same as this distance, no matter where we are at on the parabola. We'll try to do an animation in class, so again you can see that, get a good visual for that. Again, we're going to be trying to graph these and pick out some important points of parabolas. Here's a handy chart that you should write down, and I'll just give you some time to do it, but it just shows the two different types of parabolas. The ones that open right and left, and the ones that open up and down. I see a little mistake here, I believe, and I'll try to correct that here so you can get this right in your notes. Over here, let's see, if I have this one down here should be up, opens up, and opens down. Those two words we should correct. Otherwise, take some time and write down the items in this chart, and we'll go through a couple examples after that. Alright, here's our first example. We want to try to find the vertex, the focus, the directrix, and then be able to graph this particular parabola. So this one's already in a pretty nice form here, as you can see by the table we did earlier. What we like to really focus on now especially is this number right here. If we can isolate that to be a number, that's really good, because this value right here will always be something called 4p. And so in this case 4p equals 8, that means p equals 2. And that's kind of a key number because that tells you both the distance from the vertex to that line and also from the vertex to the focus point. So that's probably about all we need to know before we go to the graph here, which is my next slide. So our vertex point is 3, -1, based on what we had back there. So I'll plot that first, 3, -1. Now because that p value was 2, as we said, we're going to have 2 units either way. Now we have to also decide, is this going to be a parabola that opens upward, downward, or left-right? Well, anytime you have an x squared, it's going to be a vertical orientation. So this is going to be a parabola that opens upward like this. So what we need to do then is find that p is 2, so 2 up from there. This is going to be where that focal point is. And then 2 down from here will be where that directrix line is. So here's that directrix sneaking across here like this. And that directrix then has the equation y equals -3. We said that our actual parabola will open upward like this. We don't have to be too terribly accurate about graphing it like that. That's my vertex point, which is, I'll jot this down. My vertex point would be 3, -1. And lastly, my focus point, remember only one focus in this kind of conic section, would be 3, 1. 2 units apart. So there's our first parabola that we have graphed. And we could solve for y and graph on our calculators to check on that. I don't think we'll take the time to do that right now, but that is an option that you could do, especially on those ones that are orientated vertically where we can solve for y. Not always so easy to do this, although it's useful. Alright, let's take a look at this example. Again, we can recognize this as that general form because everything's together. One thing on the general form of a parabola, notice you'll only have one squared term and everything else will be linear. But again, what we want to try to do is get it in that same kind of nice format. So it looks like I'm going to try to group my y's together here. So I have y squared plus 2y. And then on the other side it looks like I'll have -12x plus 23. Now in this case it looks like I could actually complete the square here a little bit on my left side. So sure enough, there's that number I focus in on, the 2. I take half of that, which is 1, and I square it. So I'll add 1 to this side. I'll also add 1 to this side. So now what I have on this side, on the left side anyway, will be y plus 1 squared. Meanwhile, on the left, I'll have negative 12x plus 24, I think you can see here. And now I'll have some good factoring that will take place here. So I can factor out that negative 12 there, and I'll get x minus 2. So I think you recognize this is already the format that I'd really like here. Just by looking at this, I can see that my vertex is going to be the point 2, negative 1. The directrix then, by the way, this is going to be one of those parabolas that opens up sideways. It has that horizontal orientation. And because this is a negative number here, I know it's going to actually open up to the left. So I can conclude then that that directrix, and we'll be graphing this too in the other, my graph coming up here a little bit. My directrix this time is going to be the line x equals 5, and my focus, oh, and by the way, I should have one more thing I kind of forgot to do here. How do I determine what that is? Well, remember this value there, that's what 4p equals. So 4p equals negative 12. That means p must be negative 3, actually just a distance of 3. So the distance from the directrix to the vertex, as well as the distance from the vertex to the focus, has to be that 3 number there. And so that's why the coordinates of the focus then will be negative 1, 1. And if I go ahead and graph this, so as we said before, my vertex was at 2, negative 1, which is right here. I know my vertex or my parabola is going to be opening to the left. I said my directrix is x equals 5. So that's a vertical line right here. My focal point, we said, was negative 1, which is right here. So my actual parabola then opens to the left and looks like this. All right, so we'll continue to work on this in class. I think the parabolas are oftentimes the toughest ones of these conic sections to really grasp. However, parabolas are probably the most common real-life things. One of your items on the right side is to look for some conics in real life, and the parabolas, of course, are the most common. Satellite dishes. If you've ever been to St. Louis, there's the Great Arch. Here's some dolphins jumping like that. Just to conclude, I have a little joke, if you will. So what did the dolphin say when he accidentally bumped into the whale? "I'm sorry, sir, I didn't do it on purpose." All right, thank you very much, and we'll see you guys in class.